Question 38. The diagram shows the structures of two isomeric dicarboxylic acid, X and Y. In this X and Y, there is a CC double bonds there. Okay, means X and Y is possible to form the cis-trans isomers. Okay, for X, the dicarboxylic acid at the same site. So this is a cis isomer. For the Y, the dicarboxylic acids at different sites. So this is a trans isomer. X can be reduced to compound P with empirical formula C2H5O. Y also can be reduced to compound Q, and empirical formula is C2H5O. So now, which statement is correct? So for the X, I already told you is a cis isomer. So the answer, it just could be A or B. Now we need to identify compound P and Q, whether they are identical or not. Okay, so let's start with this reaction. For the reductions of this isomer, so let's use this X isomer, the cis isomers as example. If only the carboxylic acid reduced, means oxygens will be removed and the carbons will add 2 hydrogens there. So eventually it will form this diol, and the CC double bonds remain. Okay, this compound will form when only the carboxylic acid get reduced. So which will give the C4H8O2. The empirical formula is a C2H4O, which is not really fit the statement, because the X, after it get reduced, it must have the empirical formula C2H5O. Since the reductions of the carboxylic acids will produce this empirical formula, so it means the reductions will not follow this way. Okay, so let's try the reductions for both carboxylic acid and the CC double bond. Okay, so for the carboxylic acid, once it gets reduced, it will form this diol, as I told you just now. If the CC double bonds here now is being reduced, means add 2 hydrogens there, so it will form this part. So it will form this diol without the CC double bond. And the molecular formula for this diol, butane 1,4 diol, is a C4H10O2. The empirical formula is C2H5O, which is fit the statement. So we know that the X will form the compound P, and the compound P must be this one, the butane 1,4 diol. If now we use the isomer Y for the same reduction, so it will produce this diol. Okay, these oxygens remove, add 2 hydrogens there. Okay, add 2 hydrogens there, and the CC double bond also pi bond split, add 2 hydrogens there. So eventually it will form this compound. It will form the same compound, butane 1,4 diol. There is no cis-trans isomer there because the CC double bonds is no longer there. So since for the reduction of X and Y, they're able to produce the butane 1,4 diol, which is the same compound. Okay, therefore we know that the answer is A. Okay, X is a cis isomer. Compound P and Q, they are identical. Okay, which is the butane 1,4 diol that I told you just now. Answer therefore is A. That's all. Thank you.